Good morning. My name is Fabiana Gennari. I am a researcher from the National Commission of Atomic Energy and the National Council of Scientific and Technological Research from Argentina. I will speak about different physico-chemical techniques using for investigating carbon dioxide capture and carbon dioxide conversion. In particular, this type of reaction occurs between carbon dioxide gas and a solid and a liquid in a different process, in particular some activated by mechanochemical energy and other activated by thermal energy. And in the first case, the reaction occurs inside of the reactor, which is the milling chamber, and the solid is put inside of this milling chamber and placed in contact with carbon dioxide gas at high pressure, and by action of the moving of the balls in contact with the solid, by impact and friction, the reaction can occur. The other option is the thermal activated reaction, in which the solid is inside of the reactor in a flow system or in a batch system using a temperature and also pressure of carbon dioxide. The question is, how can we study and follow carbon dioxide capture and conversion process? Like we have a gas, it's important to follow the change in the gas composition and the formation of different compounds, in particular the desired compound like methane, by, for example, gas chromatography and mass spectroscopy, and also, in particular, for carbon dioxide capture reaction, it's important to follow the change of the mass in the solid during the incorporation of the carbon dioxide with the temperature. These techniques that allow follow this reaction is the thermogravimetry. Another important technique is the combination of thermogravimetric with differential scanning calorimetric, because it's possible to correlate the change in the weight with the different absorption and release of the heat. Regarding the solid phase, there are different techniques very important to understand which is the process occurring during the carbon dioxide capture or the conversion, in particular to study the structural and microstructural changes. In this case, for example, Raman spectroscopy, infrared spectroscopy, X-ray spectroscopy are also important techniques which provide information about the phases present at different stage of the reaction, the surface composition, also the crystalline size, and the stresses inside of the solid. Another important techniques useful to understand the changes during the reaction with carbon dioxide are the scanning electron microscopy, transmission electron microscopy, in combination with energy dispersive X-ray spectroscopy. In this case, the information obtained is the chemical composition, crystalline size and agglomerate size distribution, and also information about nanoscale regarding the nanoparticle decoration and other changes in the morphology. Finally, textural properties are also important. These type of properties are obtained by nitrogen absorption isotherm, in particular specific surface area, pore size distribution, and pore total volume of the material. Finally, these study techniques are key to determining the potential of material for carbon dioxide sorption and carbon dioxide conversion applications.